Hi everyone, welcome you all to the brilliant group of institution. Here we are going to discuss the most important question from the chapter Aldehydes, Ketones and Carboxylic acid. You know that it is the most important chapter for your term 2 examination even in chemistry. Okay, so I'm just going to the question number 1. Let us start from the IUPAC nomenclature. Okay, for the chapter Aldehydes, Ketones and Carboxylic acid. So question number 1 we have, name the following compound according to the IUPAC nomenclature rule. So this is the compound given. Let me just expand the compound. I can write it as CH3, CH. On the CH there is a CH3 as a branch. Then CH2, CH2, CHO. Right? This is the compound we have. And you know, as per the IUPAC nomenclature rule, we have to select the longest chain first of all, which is the longest chain which include your functional group. Here the functional group is aldehyde. So aldehyde including chain 1, 2, 3, 4, 5. Right? Aldehyde should get the lowest number. And fourth position you have methyl group. So let's go for the name 4-methyl. 4-methyl. Total there are 5 carbon. Therefore pentan. Right? It's a aldehyde, right? So we can say pentanal, or we can say 4-methyl pentan 1-al, because the aldehyde is on first carbon, but you know, first carbon there is no importance. So 4-methyl pentanal or 4-methyl pentan 1-al, that's also fine. All right. Question number 2. Let me just expand the compound. CH3, CH2, CO. You know, CO means keto group, right? CO, then CH. On the CH, there is a C2H5. What is C2H5? You know, ethyl group, right? Ethyl branch. Then again, CH2, CH2, Cl, right? CH2, CH2, Cl. You can take the longest chain here, 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6, right? But chlorine is there, so we can better to select this one. Which is the major functional group in this compound? Ketone is the major functional group. So ketone should get the lowest number. So number 1, number 2, number 3, number 4, number 5, number 6. Alright. Fourth position you have a ethyl branch. And sixth position we have chloro group. Alright. You know, alphabetical order, if two different branches comes, you know, it's starting with the E, starting with the C. Alphabetical order C is first, right? So 6-chloro, sixth position there is a chlorine. Though we can write 6-chloro. And fourth position ethyl, 4-ethyl, alright, 4-ethyl, 6-chloro, 4-ethyl. Total there are 6 carbon in the chain, therefore hexane, it's an alkane chain, right? Alkane chain, so hexane. Third position there is a ketone, so we can say 3-on. Right? 6-chloro, sixth position chlorine, fourth position ethyl, total 6 carbon hexane, and third position there is a ketone. Alright. Question number 3. Where is question number 3? Here we have the compound. Let me just write CH3, CH, double bond, CH, single bond, CHO. Here two functional groups are there. One is the aldehyde, one is the alkene. Which is the major functional group? Aldehyde is the major group. So number 1, number 2, number 3, number 4. Total there are 4 carbon atom. Therefore we can write bute. Second position there is an alkene. Therefore 2N. And first position there is an aldehyde, 1-al. Bute 2-ene 1-al, or you can say bute 2-enal. Right? 1 there is no important. Bute 2-enal. That's also fine. Question number 4. CH3CO. It's a ketone. CH2, CO, CH3. The longest chain is this one, 1, 2, 3, 4, 5. Second position and fourth position, 2 ketones are there, right? So, and total 5 carbons in the compound. So, we can say pent or pentane. It's an alkane chain, right? Pentane. Second and fourth position, 2 ketone. Therefore, 2,4-dione. Pentane or pentan, 2,4-dione. Second and fourth position, 2 ketone, dione. Alright. Last question. Here we have CH3, CH. On this CH, there is a methyl as a branch. Again CH2, C. On this carbon, 2-methyl group. Alright. 2-methyl group. So please expand it. Otherwise, there is a chance to make mistake. Alright. This is the compound. Which is the longest chain, dear all of you? The longest chain is now 1, 2, 3, 4, 5, 6. All right. And ketone is the major group. So number 1, 2, 3, 4, 5, 6. Fifth position, 1 methyl group. Third position, 2 methyl group. So what is the name? 3, 3, 5. Right, third position, 2 methyl groups are there. So if the 2 groups are on the same carbon, we have to repeat the number twice. So 3, 3 dimethyl, 3, 3, even 5 also, there is a methyl group. So 3, 3, 5, total 3 methyl group, right? So we can say trimethyl, and total there are 6 carbon atom, and second position there is a ketone. So we can say hex and 2-on. Hex and 2-on. 3, 3, 5, trimethyl, hexane, second position there is a ketone, 2-on. That's a IUPAC name. Clear? So dear, when you studying a organic chapter, it's compulsory to make a perfection in the IUPAC nomenclature, then only you have to enter into the chapter. Let us go to the next question. Draw the structures of the following derivatives. Question number 1, the 2,4-dinitrophenylhydrazone. You may study it. 2,4-dinitrophenylhydrazine. That is called what? The 2,4-DNP test. Right? You know, 2,4-DNP test is given by all aldehydes and ketones. Right? So 2,4-dinitrophenylhydrazone of benzaldehyde. So let me take your benzaldehyde here, all of you. You know, benzaldehyde is what? Benzene with CHO. Let me write CHO group like this. Okay, it's benzaldehyde, right? Okay, let me treat this benzaldehyde with the 2,4-dinitrophenylhydrazine. Dear student, the product, this is the product. Okay, 2,4-dinitrophenylhydrazone is the product. All right, 2,4-dinitrophenylhydrazine is the reactant. What is the 2,4-dinitrophenylhydrazine? Dear student, this is our phenyl group. All right, and with NH2, this is called hydrazine. You know, NH2 is called hydrazine, which is on phenyl group is called phenylhydrazine. And second position and fourth position, there are 2 nitro group. This is our compound called 2,4-DNP. 2,4-DNP. What is 2,4-DNP? 2,4-dinitrophenylhydrazine. When this compound treated with a benzaldehyde, what can happen? You know that any aldehydes or ketone you treated with 2,4-dinitrophenylhydrazine, it will form 2,4-dinitrophenylhydrazone. Very simple to write the product. From the NH2 group, please take this hydrogen. From this aldehyde or keto group, take the oxygen. Enough. H2O, you remove it. So water, please remove it. Remaining compound you just club together. So here we have a benzene ring and remaining CH, right? Remaining there is a CH carbon. Then there is a double bond. Where is this double bond connected? Here, nitrogen left there, nitrogen. On this nitrogen, the remaining compound means NH, the phenyl ring, and here one nitro group. Here one nitro group. This is the compound called 2,4-dinitrophenylhydrazone. So dear all, any aldehydes or ketone when you treated with a 2,4-DNP, the final product is called what? 2,4-dinitrophenylhydrazone. Okay, very simple. Just to remove water from that. Next question. Cyclopropanone. What is cyclopropanone? Cyclopropanone, right? This is the compound. So let me just draw like this. This is the compound called what? Cyclopropanone. This is cyclopropane with a ketone, right? So ketone, right? This is called cyclopropanone. Oxime. You know, when a aldehyde or ketone can be converted into oxime when the aldehyde or ketone treated with hydroxylamine. What is hydroxylamine? NH2OH. This is called hydroxylamine. So any aldehyde or ketone when you treated with hydroxylamine, here also you have to do the same procedure like the previous case. From this NH2 group, take this hydrogen and this oxygen, remove as water, remaining group just together. So let's write the cyclopropane there is a double bond, all right, double bond. This oxygen, hydrogen already gone. Then what is left here? NNOH. This compound is called what? Oxime, right? Oxime, right? So this is the compound called cyclopropanone oxime. Next one, the semi-carbazone of cyclobutanone. So our starting material is cyclobutanone. What is cyclobutanone? We can draw like this: cyclobutane with a keto group, any one of the side. This is called cyclobutanone. It is treated with a semi-carbazide. Dear student, what is semi-carbazide? Semi-carbazide is NH2, NHCO, NH2. This is called semi-carbazide. Okay, NH2 is called hydrazine, NH2, NHCO, NH2 is called semi-carbazide. Here also the same procedure. But in semi-carbazide, you have studied very important concept here all. There are two NH2 group, one left, one right. From which side we have to take the hydrogen? That's very important, right? So let me take the hydrogen which is away from the CO group. Always when you treating a aldehyde or ketone with a semi-carbazide, please take the NH2 group which is away from the CO group. I'll tell you in the upcoming questions what is the reason. You have already studied that, okay? So this H2 and oxygen remove, remaining just club it. So we have the compound cyclobutane, there is a double bond and remaining NNHCO, NH2. When you treated a aldehyde or ketone with a semi-carbazide, the product is known as what? Semi-carbazone. Okay, so easy to write everywhere we are removing water. Next question. Predict the product when cyclohexane carbaldehyde react with the following reagent. Okay, what is your starting material? Cyclohexane carbaldehyde. What is cyclohexane? You know, this is called cyclohexane. Carbaldehyde means there is a aldehyde group. There is an aldehyde group. This is the compound called cyclohexane carbaldehyde. Why the name cyclohexane carbaldehyde? Can we call it as cyclohexanol? No. Because when you say cyclohexanol, the aldehyde carbon is not included in the name. Yes or no? Cyclohexanol means total there are 6 carbon including aldehyde. But you know, there are 6 carbon, but the 7th carbon is which one? Means actually the number 1 carbon, that is aldehyde. So total 7 carbons are there. So if you want to specify that CHO group also, we have to use the name cyclohexane carbaldehyde. Now perfect, carbaldehyde, that carbon on the aldehyde is specified. Alright, so this is the compound cyclohexane carbaldehyde. It is treating with the dear all C6H5MgBr. What is C6H5MgBr? This is our Grignard reagent. Yes, dear all. You know what happened when a Grignard reagent, here magnesium positive, the alkyl or aliphatic aromatic part is the negative one. This negative nucleophile will attack on this carbon and this O becomes O minus. So let us write the product dear all. I have cyclohexane. And here we have CH, this O changes to O minus, to this part C6H5 phenyl ring attack. Then where is our MgBr? This Mg plus, right? This is the positive part, it will go to this negative part. So you will get Mg plus and Br. You know the next step, what we are doing? Addition of water in presence of acid, that is called acid hydrolysis. You know, water contain 2 ion, H plus and OH minus, right? H plus and OH minus ions are there. Where you want to place this H plus and OH minus, please distribute here to the O minus part, add H plus. So it becomes OH. And you don't need to bother about the byproduct. MgBr will go with OH. Okay, we need our major product. So cyclohexane with CH and here C6H5 and here we have OH, we will get alcohol, right? Alcohol. So a aldehyde, you know how to prepare a alcohol. All type of alcohol we can prepare from aldehyde and ketone by treating with the Grignard reagent. Next one, what is Tollens reagent? Very important question from this chapter. What is Tollens reagent? You know, Tollens reagent is called ammoniacal silver nitrate. Ammoniacal silver nitrate. In the previous video, we already discussed about Tollens test, Felling's test, iodoform, 2,4-DNP, everything. Those who didn't understand the concept, please watch it carefully. What is Tollens reagent? That is called ammoniacal silver nitrate. What is the representation? Everything you know. Let me take our starting material as cyclohexane carbaldehyde CHO. Tollens reagent, you know, it is expressed by AgNH3 twice with the overall charge of the complex is positive. This is our Tollens reagent, ammoniacal silver nitrate. You know, Tollens reaction is happen in presence of a base, therefore OH minus. What is happening during a Tollens test? You know, Tollens test is given by, all of you please underline the statement. Tollens test is given by only aldehydes. Aliphatic and aromatic aldehydes can give Tollens test. Ketone won't give the test, okay? So what is the test? The aldehyde part is converted. Aldehyde undergo oxidation. It will give you carboxylic acid, which means cyclohexane with COO minus. Means their acid part. So aldehyde converted to acid part. What are the byproducts? You know, the silver ammonia deposit. Silver and ammonia along with which one? Water. These are the byproducts common in every Tollens reaction. These are this silver. The silver is deposited the bottom part of the test tube. Therefore, it is called silver mirror test, right? Tollens test is also known as what? Silver mirror test. So this is the reaction. Zinc amalgam and in the acidic medium. You studied zinc amalgam. Zinc amalgam in this chapter of aldehyde we studied in the preparation of aldehyde, in the reduction part of aldehydes and ketone. You studied the very two important reduction that's called Clemmensen reduction and Wolff-Kishner reduction, right? Purpose is same but reactions are different. Zinc amalgam with HCl, what is that? Clemmensen reduction. So let me take our starting material once again. This is our cyclohexane carbaldehyde. Let us treat with a zinc amalgam, mercury, along with which one? HCl. Zinc amalgam and HCl, when you treated, the aldehyde part is converted to hydrocarbon, which means it's converted to CH3, alkane part. The aldehyde and ketone part you can make into alkane, hydrocarbon, through which one? Clemmensen reduction, treating with the zinc amalgam and HCl. All of you, in this point, let me tell you one more important topic. Please focus on Wolff-Kishner reduction also. Okay, next one. Which of the following compound would undergo aldol condensation, which the Cannizzaro reaction, and which neither? Write the structures and the expected product of aldol condensation and Cannizzaro. Very important question for your examination. Let me tell you the theory once. You may studied aldol condensation. Dear student, if the aldehyde need to undergo aldol condensation, two important conditions are there. First one, the aldehyde should contain at least one alpha hydrogen. Okay, aldol condensation, in order to undergo the aldehyde aldol condensation, the aldehyde must contain at least one alpha hydrogen. And second one, the reaction takes place in presence of dilute base, NaOH, dilute alkali, NaOH, dilute NaOH, dilute like that. What about Cannizzaro reaction? Cannizzaro reaction is just opposite condition of aldol condensation. Dear student, there is no need of alpha hydrogen. Alpha hydrogen should not be there in the compound, then it can undergo Cannizzaro reaction. Second one, it is happen in presence of, the reaction takes place in presence of concentrated base. For example, concentrated NaOH, concentrated KOH, etc. Okay, so just opposite. Let's go. First one, methanol. Our first duty, methanol can undergo the reaction or not. Let's check it. What is methanol, dear student? One carbon contain aldehyde, that is HCHO, right? This is methanol. Is it contain alpha hydrogen? No, dear all. What is alpha hydrogen? When you consider the ethanol, suppose ethanol is the compound, you know which is the major functional group in this compound? Aldehyde. This is the functional group. Main functional group directly connected carbon is called alpha carbon. Main functional group directly connected carbon is called alpha carbon. On the alpha carbon, the hydrogen is there. Yes, they are called alpha hydrogen. On the alpha carbon, you can see 3 alpha hydrogens are there. Okay, so what is alpha hydrogen? The alpha carbon contained hydrogens are called alpha hydrogen. At least one alpha hydrogen should be there in the compound in order to undergo aldol condensation. So can it undergo the reaction? No. What is this compound? HCHO. This is the functional group. Dear student, nearby any alpha carbon? No. So no alpha hydrogen. It cannot. It doesn't contain any alpha hydrogen. So tell me whether it can undergo aldol condensation or Cannizzaro reaction. Cannizzaro reaction, because that doesn't contain alpha hydrogen. So let me mention, it can undergo Cannizzaro reaction. Cannizzaro reaction. All right. Let me just tell you about this one also. Okay, 2-methyl-pentanol. What is the structure? Pentanol means total 5 carbon atom. 1, 2, 3, 4, 5. One of the group is aldehyde. Second position, 1, 2. Second position, there is a methyl group. All right. So this is the compound. The second one. Can you tell me whether it can undergo Cannizzaro reaction or aldol condensation? Is it contain alpha hydrogen? Yes. This is the major functional group. Nearby carbon is called alpha. It having one hydrogen. So it can undergo aldol condensation. Hope you clear that meaning. Now let us go for the reaction. Methanol. So let me take methanol, HCHO plus HCHO. Dear student, Cannizzaro reaction, it is the reaction between two same aldehydes. So methanol is there. Let me take one more methanol. It's very easy to write the product. Don't forget to write the main component on the arrow. I told you Cannizzaro reaction happen in presence of concentrated base. So let us write concentrated NaOH. All right. Now let us write. What is very simple to write the product, dear all. Listen carefully. The first aldehyde you converted into its corresponding alcohol. No change in carbon, okay? It's contain one carbon. So what is the one carbon contain alcohol? Methanol plus. Once again, the first aldehyde you convert into the corresponding alcohol. Methanol is there, methanol. Okay. Suppose here they given ethanol. Ethanol. Alright. What is this? Here also one carbon contain aldehyde that you converted into one carbon containing acid. First aldehyde converted to the alcohol, second aldehyde converted to the corresponding acid. Here one carbon is there, which is the one carbon contain acid, methanoic acid, HCOOH. But carefully all of you, your system contains sodium, right, as a base. You know, sodium is a highly reactive metal. He will displace this hydrogen. He can displace this hydrogen. So you will get COONA, sodium salt of methanoic acid. So during every Cannizzaro reaction, the one aldehyde converted into its corresponding alcohol, the other aldehyde converted to the corresponding salt of acid. If you are using potassium hydroxide here, you have to write potassium salt of the acid. If they given sodium hydroxide, you should write as sodium salt of the acid. All right. Next question, 2-methyl-pentanol, we already discovered it can undergo aldol condensation. You know, aldol condensation is the reaction between two same aldehydes. So let me take the same compound once again. Okay, this is the compound. We have 2-methyl-pentanol, 2-methyl-pentanol. All right. I told you aldol condensation reaction takes place in presence of a dilute NaOH. Alright, perfect. Let's go for the reaction. I'll tell you a simple method how to write the product during aldol condensation, dear all. From your second compound, this is the first compound, second compound. In the second compound, this is the aldehyde, right? This is the alpha carbon, right? Okay. And this is the alpha hydrogen. Clear? From the second compound, take the alpha hydrogen and transfer into the, I'm just writing the CHO group in the first compound as CHO, okay, CHO, all right, perfect. Here, from the second compound, take the alpha hydrogen, just one alpha hydrogen, okay, one alpha hydrogen and transfer into this aldehyde part of the first compound. Please don't write these arrows during examination, so only to understand the concept. From the second compound, take one alpha hydrogen and transfer into the first compound aldehyde, the O group. Then the O becomes OH. If this hydrogen reaches, this O becomes OH, alcohol. Alright. Then one more purpose. From which carbon you transferred the hydrogen? This carbon. Alright. That carbon you have to make a connection with the aldehyde carbon of the first compound. Once again I am repeating, two steps are there you have to write during aldol condensation. From the second compound, take one alpha hydrogen, this is the alpha hydrogen, transfer into the first compound CO group, oxygen. So O with this hydrogen becomes OH, alcohol. Then connect the carbon, which all carbon? From which carbon you transferred hydrogen? This carbon, right? Okay, that carbon you make a connection with the aldehyde carbon of the first compound, this carbon. Then clear. So let me write the product starting from here. Okay, I'm starting from here. All of you check it. I'm starting from here. CH3. Then we have CH2. Then again CH2. Then again CH, in which there is a CH3. And here what you have? CH. I told you this oxygen already becomes OH, alright, OH. Now this carbon you have to make, this carbon, CH carbon, you have to make a connection on this carbon, okay. So I'm writing this carbon, dear all, this carbon, okay, this carbon having which all groups? One CH3 is there, okay, one CH3 is there. And here CH2, CH2, CH3. Let me just write above CH2, CH2, CH3. And what you have? CHO. This is the compound. This is the compound going to form during the reaction. Okay, this is the aldol which is forming. Why it is called aldol? Because it contains aldehyde and alcohol. Therefore, it's called aldol. Aldol, aldehyde and alcohol, aldol. Next question. Benzaldehyde. Okay, benzaldehyde. The same question. Okay, same continuation. What is benzaldehyde? Dear student, you know benzaldehyde is benzene with a CHO group. Benzene with a CHO group. Can you tell me, is it contain alpha hydrogen? Is it contain alpha hydrogen? No, dear student. This is our aldehyde functional group. So nearby carbon is called alpha carbon. Is it contain any hydrogen? No, they already completed their all 4 valency with other carbon atom, no hydrogen. So if there is no hydrogen in the system, it can undergo Cannizzaro reaction. Alright, benzaldehyde also can undergo Cannizzaro reaction. Cannizzaro reaction. Alright. So let us write the product, all of you. I'm taking benzaldehyde as a starting material. You know benzaldehyde is benzene with the aldehyde. During Cannizzaro reaction, we have 2 same species, right? Okay, let me take one more aldehyde. Tell me, dear student, during Cannizzaro reaction, we need a strong base or a weak base? Strong base, okay. So we have to use concentrated NaOH or KOH, alright. What we discussed during Cannizzaro reaction? The first aldehyde, without changing the number of carbon atom, it's converted into its corresponding alcohol. This is benzaldehyde, which means there is a benzene ring with a CHO group. So I can make it as CH2OH. Okay, maintain the structure, maintain the carbon and make them into alcohol. Plus, I told you the second aldehyde we have to convert into corresponding acid. So benzaldehyde, its corresponding acid is which one? Benzoic acid. But can we write benzoic acid directly? No, because sodium is there. The sodium can replace this hydrogen. So you will get COONA, sodium salt of benzoic acid. Clear all? What about cyclohexanone? What is cyclohexanone? Cyclohexane with a ketone. Cyclohexanone can undergo Cannizzaro or aldol condensation. Come on, everyone. What do you think? This is the functional group, right? CO is the functional group. Nearby carbons are called, this is alpha, this is alpha. Yes, you know, both of the alpha carbon contain hydrogen atom. Yes, enough to undergo aldol condensation. So it can undergo aldol condensation. All right, aldol condensation. Let us write the product. Let me take one cyclohexanone. Alright, cyclohexanone plus another cyclohexanone. Alright, ready? You know, aldol condensation happen in presence of a dilute base, right? Dilute NaOH. Okay, right. How to write the product? Hope you know the previous topic, what we learned, the same procedure you can follow here yesterday. From the second compound, what we discussed, from the second compound, this is the functional group. So this is the alpha carbon. This is also alpha carbon. Any one of them you can take it. It contains 2 alpha hydrogen, right? Because this 2 carbon valency over, then remaining 2 hydrogen. Okay. From the second compound, I told you take one of the alpha hydrogen and transfer into this oxygen. Once again, I'm repeating, please don't write during this examination, okay? Only to write the product directly. This hydrogen, this hydrogen you take from the second compound. Which hydrogen? Any one alpha hydrogen. Transfer into the O and this O becomes OH. Now, which all carbon atoms I told you to make a connection, dear all? From which carbon you transferred hydrogen? This carbon, you make a connection with the aldehyde or ketone carbon. Okay, now I'm going to draw the final structure. Okay, let me draw this cyclohexane ring first of all. Okay, ready? And I told you this O changes to what? OH. Alright, OH. O changes to OH. On this carbon, this carbon is connected. Alright. On this carbon is connected. Okay, on this carbon, nearby there is a CO group. Nearby there is a CO group. Check it all of you. Is it correct or not? This oxygen we made into OH. Okay. This carbon means this carbon we have to make a connection with this carbon. Alright. This is the carbon. Nearby there is a CO group. Clear all of you?
Brilliant, Qatar. Your trusted coaching partner for IIT, JE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant, Qatar.